Come with me on a journey. Let's travel through the vast, silent darkness of space to visit the family of worlds that orbits our home star, the Sun. Our solar system is our local address in the immense Milky Way galaxy. 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, each with its own story. These worlds are cosmic laboratories, holding clues to our origins. By exploring them, we embark on one of humanity's greatest adventures. This journey is about understanding our place in the cosmos, so strap in, our grand tour is about to begin. Our first stop is a world of extremes, a tiny cratered sphere huddled perilously close to the Sun. This is Mercury, the fastest planet in our solar system, completing its year in just 88 Earth days. Its proximity to our star means it endures a relentless bombardment of solar radiation and temperatures that can swing wildly. By day, the surface is hot enough to melt lead, reaching over 800 degrees Fahrenheit. But with virtually no atmosphere to trap that heat, the night side plunges into a deep freeze, hundreds of degrees below zero. It's a testament to the brutal, unforgiving nature of space when you're this close to a star's furnace. Yet this harsh little world is not without its mysteries and its lessons. Its oversized iron core, making up a huge percentage of its mass, challenges our models of how planets form. Did a colossal impact in the distant past strip away its outer layers? Or did it form this way, a dense anomaly from the beginning? Scientists study Mercury's ancient battered surface to read the history of the early solar system, a history of violent collisions and planetary construction. It's a primordial relic, a Rosetta Stone for understanding the very building blocks of worlds, including our own. Venus, once thought to be Earth's twin, beckons us with its mysterious yellow clouds. But beneath, the reality is harsh. Crushing pressure and a runaway greenhouse effect make it hotter than Mercury. Venus is a cautionary tale, showing us how fragile a planet's habitability can be. By studying Venus, we learn how vital it is to protect our own precious atmosphere. Now, we return home, to a world that is, as far as we know, unique in the entire universe. This is Earth, our cradle, our sanctuary. From a distance, it is a pale blue dot, a swirl of white clouds, blue oceans, and green and brown continents. But up close, it is a symphony of complexity and diversity. It is the only place we know of where the cosmic ingredients, the right distance from a stable star, the presence of liquid water, a protective magnetic field, and a breathable atmosphere, came together in just the right way to ignite the spark of life. A spark that, over billions of years, evolved into the breathtaking biodiversity we see today. From the deepest ocean trenches to the highest mountain peaks, life has found a way. It has adapted, diversified, and transformed the very surface and atmosphere of our planet. The oxygen we breathe was produced by countless generations of tiny organisms. The soil that grows our food is the product of millennia of life and death. We are not merely living on Earth, we are Earth. Our bodies are made of its elements. Our rhythms are tied to its daily rotation and yearly orbit. To study Earth is to study ourselves, to understand the intricate, fragile web of connections that makes our existence possible. It is the standard by which we measure all other worlds. Mars, the red planet, has captivated us for millennia. Its rusty, dusty surface hints at a time when water flowed freely. We see dried-up riverbeds and ancient lakebeds, evidence of a warmer, wetter past. Our robotic explorers search for clues. Could life have once existed here? Every rock and soil sample brings us closer to answering, are we alone? We now cross a great divide in the solar system, the asteroid belt, and approach a true giant. This is Jupiter, a world so immense that all the other planets could fit inside it. It's not a world of solid ground, but a colossal ball of gas, primarily hydrogen and helium, the same ingredients that make up the Sun. Its sheer size and gravitational might make it the undisputed king of our solar system. It acts as a great cosmic bouncer, its gravity shaping the orbits of asteroids and comets, likely protecting the inner planets, including Earth, from countless impacts over the eons. Jupiter is a world of unimaginable power and scale. Its famous Great Red Spot is a storm that has been raging for centuries, a storm larger than our entire planet. Its colorful bands and zones are jet streams of ammonia and water clouds, whipped around the planet by winds blowing at hundreds of miles per hour. It's a failed star, a glimpse into what might have been if it had gathered just a bit more mass. Studying Jupiter helps us understand the dynamics of gas giants. which we now know are common throughout the galaxy, and reveals the powerful gravitational forces that sculpted our solar system into the form we see today. Continuing our journey into the cold outer reaches, we come to what is arguably the most beautiful and iconic world in our celestial family. This is Saturn, the ringed planet. While other gas giants have rings, none are as spectacular, as grand, or as bright as Saturn's. From a distance, they look solid, like a celestial halo, but up close we see they are an impossibly vast, complex system of countless individual particles of ice and rock, ranging in size from dust grains to mountains, all orbiting the planet in a disk thinner than a sheet of paper, proportionally speaking. These rings are a dynamic and wondrous natural laboratory. They teach us about how planetary systems form and evolve. The intricate dance between the ring particles and Saturn's dozens of moons creates complex patterns, gaps, waves, and spokes, revealing the subtle laws of gravity at play. The rings may be the shattered remains of a moon that strayed too close, or they could be pristine material left over from the solar system's formation. By studying this breathtaking system, with missions like Cassini, we learn not just about Saturn, but about the fundamental processes that create order and structure from chaos throughout the universe. We press on into the deep, dark frontier of the solar system, to a world that seems to play by its own rules. This is Uranus, the ice giant. Unlike every other planet, which spins more or less upright like a top as it orbits the Sun, Uranus is knocked over on its side. It rotates at an angle of nearly 98 degrees, meaning it essentially rolls along its orbital path. This extreme axial tilt results in the most bizarre seasons in the solar system. For a quarter of its long 84-year orbit, one pole faces the Sun continuously, while the other is plunged into a decades-long, dark, frozen winter. What could have caused such a dramatic tilt? The leading theory is a cataclysmic collision with an Earth-sized protoplanet billions of years ago, a violent event that reshaped its destiny. This strange orientation makes Uranus a fascinating case study in planetary dynamics and atmospheric science. How does an atmosphere behave when one hemisphere receives sunlight for 42 straight years? Studying its placid-looking blue-green methane haze and its faint dark ring system helps us test the limits of our atmospheric models and broadens our understanding of the chaotic and violent history that shaped the worlds of our solar system. We have reached the final planetary outpost on our tour, a deep blue world at the edge of the known solar system. This is Neptune, the last of the gas giants. Its existence was predicted by mathematics before it was ever seen by a telescope, a triumph of celestial mechanics. When Voyager 2 flew by in 1989, it revealed a surprisingly dynamic and stormy world. Despite being the farthest planet from the Sun, receiving very little energy to power its weather, Neptune is home to the fastest winds in the solar system, reaching supersonic speeds of over 1,200 miles per hour. These incredible winds whip up massive dark storms, similar to Jupiter's Great Red Spot, that appear and disappear over time. What internal heat source drives this furious weather so far from the Sun's warmth? This is one of Neptune's greatest mysteries. As the outermost planet, Neptune's orbit helps define the boundary of our planetary system, gravitationally shaping the Kuiper Belt, a vast ring of icy bodies that lies beyond it. Neptune is our sentinel in the dark, a key to understanding the conditions in the cold, distant regions where our solar system began to form. Our grand tour ends, but our journey of discovery continues. We've glimpsed 8 worlds, each a unique chapter in the story of our solar system. These planets are an interconnected family, shaped by a common star. Studying their differences helps us appreciate the fragile uniqueness of Earth. So keep looking up. Stay curious. The cosmos awaits.